Okay, so question 1, we have the limit as x approaches 3 of f of x. So here's 3. If you look, as we approach 3, we get closer and closer to 4. The answer is 4. Question 2, what happens as we approach 6? We have to approach from the left and the right. Notice both of these are going to positive infinity because of the asymptote, so the answer is D and E. Question 3, as we approach 2, so again from the left and the right, those values are both going towards 2. Question 4, this is as we approach 1 from the left. So from the left, we're doing a one-sided limit. It looks like we're approaching 1. Question 5 says, what is the value at 3? What is the value at 3? So you got to look at 3 and find where the value is. We have an open dot here and a closed dot here. So f of 3 is negative 2. And then lastly, the limit as x approaches negative infinity. So we're going this way forever. It looks like there's a horizontal asymptote along the x-axis. So that would be 0. The limit as x approaches negative infinity of f of x is 0. Okay, so question 7. Which of these are true? So if we look at question 1, this basically says the left and right hand limits are the same at 1. So the left and right hand limits approach different values. As you approach from the left, it's 1. As you approach from the right, it's 4. So this doesn't work. Number 2, it says the limit as you approach 3. So as we approach 3, our answer is 4. And then this says the limit as you approach 1 from the right is also 4. That is true. So that is equal to 4. So this one is true. And then the third one, it says that there's, as you go to the right, there's a horizontal asymptote that's equal to the same limit as you approach 2. So the limit as x approaches infinity, this way, it looks like there's going to be an asymptote here along 2. And then as we approach 2 in general, from the left and right, that looks like 2 as well. So both of these are true. So that's why our answer is F. Question 8, it says, for what values of a does the limit of f of x equal 1? So you just got to kind of draw a line along 1. And it looks like we have a value here at negative 3 that works. And then we have these two values, and we just kind of guesstimate where they're at. This looks like at 4.2 and 5.2. So that's why we have those 3 answers. And then question 9, for what values of x do we have a removable discontinuity? So removable discontinuities are just holes in the graph. So it looks like we have one at 2 and one at 3. Okay, for the rest of the questions, it says find the following limits if possible, show all work in proper notation. So number 10, if you plug in 0, or if you plug in negative 2, I'm sorry, you should get 0 over 0, so it's indeterminate form. So let's factor the top and the bottom. As you can see, the x plus 2's cancel. And so now we're going to plug in negative 2 into the numerator and denominator. And as you can see, our answer is going to be negative 9 over 2. Question 11, so we are approaching infinity, kind of asking for horizontal asymptotes. Again, on the top, I would not distribute that. Just note that from this term, you're going to get a 4x squared out of it. Because again, it's going to be 2x times 2x. And then this 4x squared is going to multiply to the negative 3x. And so, again, when you're doing horizontal asymptotes and limits at infinity, you only care about the largest degree. And so on the numerator, our largest degree is going to be negative 12x cubed. And on the denominator, we can see we have a 4x squared, or cube, sorry. those cancel. So this is negative 12 over 4, and we got to plug in x equals infinity, but there is no x, so this is just equal to negative 3. Question 12, if we plug in 0, we're going to get 0 on the numerator and denominator, so let's factor the top and bottom. So up top, we have a GCF of x squared, and on the denominator, we have a GCF of x squared also. So our x squareds are going to cancel, and then we're just going to plug in 0 in the numerator and denominator, and that's going to give us 2 minus 5 times 0 over 6 times 0 cubed minus 1. So yeah, negative 2 over 1, which is negative 2. 13, if you plug in 3, you're going to get 0 on the numerator and 0 on the denominator. I said that backwards, but you know what I mean. So let's factor. The top is a difference of squares, so that's going to factor to x plus 3, x minus 3. And the bottom is going to be x minus 3 squared, or as I say, just x minus 3 times x minus 3. We're going to cancel out. And as you can see, when I plug in negative 3 to the numerator and denominator, I'm going to get 6 over 0. So this is going to be undefined because we do have a number divided by 0. So this is D and E, does not exist. Technically, I guess it would be positive infinity. Again, limits at infinity. Again, we only care about the largest degree on top and bottom. So we're going to look at these two. Again, when you square root the denominator, it's going to be 3 times the absolute value of x over negative 7x. Now, we are approaching infinity. So this is going to be a positive number and a positive. This is going to be negative 7x over 3 times x. The x's cancel, and we're still left with negative 7/3 because of this negative outside. These right here, these x's and the absolute value of x cancel to 1, positive 1, but we still have this part. 15, if I plug in negative 5, I get 0 over 0, so we have another indeterminate form. So if I factor the top, and I factor out a 4 from the bottom, we have some cancellations. And if I plug in negative 5 in the numerator, I'm going to get 2 over 4. Sorry, negative 2 over 4, which is negative 1/2. Okay, so we're doing x approaches 2 from the right. So if you remember the absolute value of x over x, right, the graph looks like this. And so here we're just moving it to the right too. We're transforming it. And these values are 1/3 and negative 1/3. So as you approach from the left and right, you're going to get two different limits. It does not exist. That's the easy way, but I guess let's do it the mathematical way. So technically, we got to break this down as we approach 2 from the left and 2 from the right. Okay, so now as we approach 2 from the left, we're going to be negative because this will be less than 2, like as you approach it from the right. So it's a number minus 2. So you're going to get the negative version of it. So if I wanted to substitute in the piecewise, it's going to be negative x minus 2 over 3 times x minus 2. If you cancel those out, you're going to get negative 1/3. And then versus this other one, this is the positive side because, again, you're approaching 2 from the right. So this number up top is going to be positive and positive. And again, you're going to cancel out and get 1/3. So these are two different limits. So from the left and the right, you're approaching negative 1/3 and 1/3. So the limit does not exist. And just for a little bit more clarity, remember absolute value is x. If x is less than 0, negative x. Oops, sorry, I got that backwards. If x is greater than 0, negative x. If x is less than or equal to 0. And then basically the minus 2 is the same thing. You just plug in minus 2, and this changes to a 2. So again, as we approach from the left, we're using this one because that's less than 2. All right, again, limits at infinity. Don't sweat the small stuff. So we're only going to focus on these factors. When you break up the absolute value, remember it's 2 times the absolute value of x over 5x. And so we're going to negative infinity. We're going this way. So if I plug in a negative number here, and I plug in a negative number here, the top is going to come out positive. This will stay negative. So again, this will be like negative 5. So I plug in a negative 5 here. This turns out to be positive 5, and this is negative 5. So they cancel out to a negative 1, which is negative 2/5. Again, going back to the absolute value piece, if I wanted to do this mathematically, it looks like that. Those cancel out to negative 1. A lot of these, so again, another absolute value, but we're approaching negative 1 from the left. So if you factor out the top, if you factor a 2 out of the top, you get 2 times x plus 1. And again, we're approaching 1 from the left. I'm sorry, negative 1 from the left. So that means we're going to use the negative version of the absolute value. So it's going to be 2 times x plus 1 all over negative x plus 1. Those cancel out, and you're left with negative 2. Okay, so as x approaches 0, if you plug in 0, you're going to get 0 on bottom and top, so indeterminate form. So let's factor an x out of the top and an x out of the bottom. We'll cancel out the x term. So this is going to be the limit as x approaches 0, 4x squared plus 7 over 3x plus 2. Let's plug in 0 now, and we're going to get 7/2 left over. All right, so 20. The limit as you go to negative infinity. Ooh, that's important. If I plug in negative infinity here and here, we're going to get 3 plus 4 to the negative infinity over 3 to the negative infinity minus 2. And remember, the limit as x goes to negative infinity of this equals 0. So basically this is 0 and this is 0. So our answer is going to be 3 plus 0 over 0 minus 2. And that gives me negative 3/2. 21, you don't really have to show work on this. You just got to make a note that says exponentials dominate power functions at infinity as x approaches infinity. And there you go. So basically you're going to get a number over an infinity, which is 0. 22, find the value of a that makes it continuous. So we have to check both the left and right hand limits, and they need to be equal. The limit as x approaches 1 from the left. And again, 1 from the left means that we're less than 1, so we're going to use this top equation. So what we do is we plug in 1 into the x, and when we simplify that, we're going to get 3 minus a. And then we're going to do the same thing from the right. And again, from the right means we're bigger than 1, so we're going to use this equation. Plug in 1 to it. And that's going to give me 2 plus 5a. And then now we just got to set these equal and solve. All right, and then when you solve for a, you're going to get that a is equal to 1/6, which we see right here. Okay, next one, 23. Find the value of k that makes g of x continuous. So again, we're going to plug in the left and right hand limit of 3. Right, so we're actually going to do the left and right hand limit from here, and then set it equal to k. Okay, so let's factor the top and bottom. So it looks like the top is going to be x plus 5, x minus 3. And the bottom's going to be x minus 3, x minus 7. So when we cancel out, we're going to get x plus 5 over x minus 7. So plug in 3 for x, and we should get a over negative 4, which is negative 2. And then let's just check to see if the right-hand limit is the same. And I mean, it should be, right? Because again, we're just plugging in the same value. So we're going to get negative 2 again. So basically, the left and right-hand limit are negative 2. So the limit's negative 2. And we also need to plug in 3. Because again, the value at 3 has to be equal to the limit at 3. So this is just going to be k equals negative 2. All right, so A, 24, we're going to find horizontal asymptotes. So we got to do infinities, left and right infinities, starting with number A, or I guess letter A. So the factoring of the top is going to give me, oh, sorry. So again, oh, my bad. So limits at, horizontal asymptotes are limits at infinity. So we just kind of ignore these parts. And we're going to take the limit as x approaches positive and negative infinity of k of x, which is very similar to x squared over 4x squared. Those cancel out, and so this just equals 1/4. There is no x to plug in, so that's why we get horizontal asymptotes at 1/4. If you look at part B, we do have 2 answers here. So let's start with the right-hand limit as we go to infinity. Again, at infinity, we don't care about these minor terms. So it's just consider 4x over 4x. Those cancel out and make 1. And so that's our first limit. The second one, the limit as x approaches negative infinity. Let's actually plug this one in. We get 4 to the negative infinity minus 5 over 10 plus 4 to the negative infinity. This is 0 here, and this is 0. So really, this is just negative 5 over 10, which is negative 1/2. And that's our second one. Part C. Again, we don't care about the 6 or the plus 7. We only care about the 4x squared and the negative 8x. So again, if I simplify the top, we're going to get 2 times the absolute value of x over negative 8x. And so the limits, as we approach infinity, do change the values. So again, as we approach positive infinity, these will be the same number. So like when you're like at 100 million and 100 million, right? You plug in 100 million, it's positive. You plug in 100 million here, it's positive. So these can just cancel. I mean, technically, the step is to replace it with the positive version of x. Because again, absolute values are piecewise functions, so you have to consider whether you're just taking x or negative x. We cancel, and this is equal to negative 1/4. The next limit, as we go to negative infinity, now we're going to consider the negative version of x. These cancel out, and then we're left with a negative and a negative are a positive. So this is going to be 1/4. So there's my 2 horizontal asymptotes, 1/4 and negative 1/4. And again, the reason why with this negative infinity, think of negative 10. If I plug in negative 10 here and here, this will be positive, and this will be positive. So we're going to get 2 times a positive number, and then negative 8 times negative 10. Right? So the whole thing is positive. again, is it continuous at 4? Is this function? It is, but what's the reason why? So you need to show that f of 4, that the value at 4 is the limit of the function as x approaches 4. So this needs to be true. All right, so let's do f of 4 first. It's the easy one. We're going to use this bottom equation. It's going to be 4 squared minus 5 times 4 plus 5. And that's going to give me 16 minus 20 plus 5. And that's going to give me 1. So now we just got to show that the limit equals 1. So the limit as x approaches 4 from the left. And again, 4 from the left, we're going to use this part. And again, this is going to be 12 minus 11, which is 1. So that's good. And then the limit as we approach 4 from the right. We just did that here. And again, that's equal to 1. So that means the limit as x approaches 4 from the left and right are the same. All right, both of those, we can conclude that the limit as x approaches 4 of the function is 1, and that f of 4 is 1. So it is continuous. So f of 4 is equal to the limit as x approaches 4. That's true, so it is continuous.